Okay, so let's move now back from modules again to inverters. We're actually very, very happy to have, for the first time at a Taiyang event, a Chinese company Sineng present. We have with us Habibul Jack, who is the Senior Product Manager at Sineng Electric, and he will talk about the techno-economic feasibility of inverter selection for large wafer-based high-power modules. Habibul, glad to have you. The floor is yours.
Yeah, thanks, Michael. Okay, let me share the slide. Is it visible to you?
Yes, if you go into presentation mode, then everything's perfect.
Yeah, how about
very good. Yeah, super.
Okay, great. Okay, let's get started. Hello, everyone. Good morning, good afternoon, good evening. It is a great honor to attend this conference with you all PV experts. In the presentation, my focus I will put into techno-economical feasibility of inverter and module selection for increased module power from 400 watt peak to 600 watt peak plus, which is driving an unprecedented wave of changes in array designing and inverter selection. This presentation is divided mainly into two parts. In the first part, I will be talking about module development backgrounds and trends and implication on inverter module interface with increased module power very briefly. In the second part, I will be introducing our string inverter tailored for high density module and central inverter compatibility as well. Last but not least, I will be introducing Sineng Electric and its products and the products that will be exhibited in SNEC. So here I would like to take you back to the basics of module production. Basically, silica is crystallized, and after a long process, as you can see on the screen, we get cell, and cells are later assembled into module. Then it is used in system. So in the mid of 1990 to 2020, we can see a clear growth in the wafer size. In the literature and PV Tech, these wafer are named as M0, M3, M4, and later latest M10 and M12. So these are the most popular wafer size in last decades or half. The size varies from 156 millimeter for M0 to 166 millimeter for M6, and which has power around 300 watt peak plus. But today's presentation focus goes to latest M10 and M12, which size are 182 millimeter and 210 millimeter respectively. And power is 400 plus watt peak to 500 or 600 plus watt peak, and that we have available in the market. And manufacturing high density module with 182 or 210 millimeter wafer, different kinds of technology being used like PRC, PRC-AC, multi-bus bar, half cut, etc. And some manufacturers are even using 7th generation of PARC technology. Apart from that, we also see variations in cell gap, a small gap, and zero gap is being used by some key players. And for this, there are some related CTM losses. Okay, move to the next slide. So to understand the power increment with the increment of wafer size, we need to take a step back into basics of the PV physics. You can see a PV cell on the screen. A PV cell is a current source. Basically, it is a current source. So when sunlight comes into the cell and the photon collides with the electron, and electron will flow less resistance path and flow through the cables. The number of the electron generated is directly proportional to the irradiance. So PV cell is a radiance controlled current source. Current can be increased by increasing the irradiance, or if you keep the irradiance constant and increase the cell area, you will get more current. So larger the cell area, larger the current. Though the cell area increase, but the voltage remains same due to the half cut technology. Vendors basically cut not only the cells into half but modules too, and connect series connected half cut cells in parallels. Thus the voltage get reduced. On the left hand side, you can see the current increment with different rating modules, and it goes beyond 15 amp, and with rear side gain of bifacial module, it reaches up to 20 or 22 ampere. For utility project, the system voltage is 1500 volt. So we don't connect module in parallel, because that would lead higher current, and cable loss will be higher. We connect them in series. So in series connection string design, which has the priority VOC or ISC. In VOC higher and ISC less case, less parallel module connection and more series connection will lead to lower BOS cost in the form of less combiner box, less cable, less land occupation, etc. For a 3.125 megawatt block with 445 watt module of 49.4 voltage connected in series, 26 per string, and 480 string parallelly. On the other hand side, 600 module of 41.4 volts connected in series, 32 per string, and 293 string gets connected in parallel. So you can see the differences. Less module will lead to less land cost, cabling, and so on and so forth, reduction of other costs. So let's discuss the module production and logistic cost. As you can see on a graphic table, 182 millimeter and 210 millimeter wafer give us less wafer cost, cell manufacturing cost, and module assembly cost. For large scale production, it is definitely economic. On the right hand side, we can see kilowatt peak that can be loaded in a 40 feet container. More kilowatt peak can be loaded with 182 or 210 millimeter wafer in comparison to 158 millimeter wafer. So considering the BOS and LCOE, 182 millimeter or 210 millimeter wafer will give more benefits. The number of the large wafer based module is needed less small wafer less wafer based module, and the other costs like mountaining, screwing, pile foundation, combiner box, and other cost will also be reduced. The overall capex will be minimized in the way which in return will give optimized LCOE. The total BOS cost will be reduced to 5 to 7% or 9% in regards to different application scenarios and project size. Okay, now we will talk about the implication on inverter and module interface. So for a module or inverter, we usually look into two values. First one is IMPP and second one is ISC. As the current of the wafer is increased 9% with the 166 millimeter and 28% with 182 millimeter and 75% with 210 millimeter wafer. So existing inverter solution will face some problem with it, and that is the limit of short circuit current and MPPT current or operating current of the inverter. So MPPT current limitation of inverter, what does really means to inverter? Operating current is controlled by MPPT tracker by varying the load, or can say controlling the voltage as seen by the string or array from 0 to infinity. When the current of the string or array will exceed the MPPT current limit, then it will move to the knee point down to the lower part of the curve. Because of that, power will be clipped. And though inverter will with lower MPPT current rating will operate, but we can't harness the maximum power from the array, and that ultimately will lose some power. So these are the solution available in the market: 185 kilowatt, 250 kilowatt, and 275 kilowatt in string inverter section. And first we look at the 185 kilowatt solution. So MPPT maximum current is 100 ampere. First of all, it has less only 3 MPPT trackers. So there are associated higher mismatch loss, which completely don't fulfill the proper purpose of using string inverter. Secondly, it has electronic breaker, which is not reliable. And for 250 kilowatt solution, maximum MPPT current is 30 amp, and there are 12 MPPT tracker. Even though 210 millimeter wafer module single string is connected with 12 MPPTs, but the DC ratio will be less than 1, as only one string of 18 amp or more can be connected with one inputs. So to get rid of this problem, Sineng Electric has come up with 275 kilowatt inverter, which is tailored for high power module, and each MPPT maximum operating current is 40 amp, and each MPPT provide 2 string interface. Okay, next. So this is our flagship product, which has a gigawatt of installation around the world. It has 115% overload capacity, and same series SB model has 120% overload capacity. The protection level of this inverter is IP65, and it is very grid friendly. It has LVRT, SBRT, and ZVRT functions, and there are many other functions equipped in this inverter. So as the maximum short circuit of the central inverter is higher, there is no constraint in array designing with high power module. However, input fuse and breaker rating of the combiner box need to be adjusted. And along with that, the DC fuse rating will also need to be adjusted. So central solution also comes with skid solution. Skid solution comprise of an inverter, a transformer, a LV cabinet, and a skid. And different DC ratio can be implemented with this solution, which can be up to 1.8. And as you can see on the screen, there are different DC ratio with different wafer size here. So This 275 kilowatt inverter tailored for high power modules. Maximum output power is 275 kilowatt, and maximum current of each string input is 20 amp. It has 12 MPPT and total 24 inputs. So with the evolving PV technology, Sineng Electric inverter has also been evolved over the years, 50 to 175 kilowatt or to 250 kilowatt. And now this 275 kilowatt inverter can work with all kinds of wafer size module, that is 166 millimeter or 182 or 210 millimeter. You can see here the different currents of short circuit current of the different kinds of module, but it is fit for all kinds of module short circuit current rating. So this DC-AC ratio can be achieved up to 1.9 with this 275 kilowatt with 182 or 210 millimeter wafer based 600 watt module, and 1.3 or 1.39 DC-AC ratio with 182 millimeter module wafer based 540 watt module, and with the Y connector 1.8 DC-AC ratio can be achieved. So higher DC-AC ratio reduce the BOS cost. On the right side on the screen, we can see the LCOE optimization for different irradiance zone in China. So in this inverter, there are many functionalities, and more functionality gives more adaptability. All the functions like PV or IV curve scanning, PLC, NT-PID, SBC or ESS interface are equipped in this inverter. And this inverter is fit for any harsh environment. It has IP66 protection level, C5 anti-corrosion grade, which gives it longer lifetime. And the operating temperature range is minus 30 degrees centigrade to 60 degrees centigrade. It also features dual MPPT solution. That means in the daytime, it will provide a floating ground using Agile NT-PID box, and at night, the reverse it will reverse the voltage to the string to recover it from the PID effect. So using IV curve features of this inverter, it can detect up to 17 kinds of module faults, like open circuit of the string and string with high resistance, low string short circuit, invalid string or abnormal module current due to shadow or glass breakage or hidden crack, etc. IV curve scanning accuracy is 0.5%, and scanning speed is less than 1 second, where in traditional method it would take less than 5 seconds. It is fast, accurate, and using it is detection of any kinds of faults become easier. This is online diagnosis without plugging out any string. For a 100 megawatt project, Synergy Cloud plus IV curve scanning features only takes more or less 15 minutes time to do a full scan and deliver the report. It will take about 1 gigabyte of data for safe learning, and it will come up with a report like which string has faults and what kind of fault it is. And this increase operation and maintenance efficiency and the generation. Okay, I cannot see the PPT here. Okay, I will talk about the milestone and achievement of the Sineng Electric. Here I will introduce the Sineng Electric. Sineng Electric was established in 2012. In 2014, we acquired Fortune 500 listed company, Immersion's PV business, and we inherited their R&D and management personnel. And okay, let me minimize it. And okay, I think there are some issue. Okay, there is no issue. So we inherited their R&D and management personnel, and it helped us grow the fast and become top 5 inverter manufacturer in the world in a very short time. In 2016, Wuxi Industrial Park was established and large-scale production was started. In 2017, we had a massive expansion of our overseas business and service network. In 2018, we founded our first overseas manufacturing base in Bengaluru, India, to meet exponentially increased market demand. In 2020, we went public and listed in Shenzhen Stock Exchange. So we mainly provide the products of 4 areas, and they are PV inverter, energy storage, power quality, and control and monitoring section. So we the one and only manufacturer in the world with 3 mainstream technology routes in the inverter section. In central inverter solution, we have products ranging from 1 megawatt to 3.4 megawatt, and integrated solution is also available for them. In central distributed inverter solution, we have products ranging from 1 megawatt to 3.15 megawatt, and integrated solution is also available for them. In string inverter, we have products ranging from 3 kilowatt to 275 kilowatt, and 50 or 60 or 110 kilowatt inverter for commercial and industrial rooftop has been adopted by many clients. The red colored solution are for 1500 volts, and the blue colored solution are for 1000 volts. So finally, I will talk about the products that we are gonna exhibit in the SNEC. So here we have high current inverter, and we will also be exhibiting string inverter for commercial and industrial rooftop, SP 60K and SP 110K, and string PCS solution, 2 kinds of solution, and the battery container. And in central PCS solution, we will show the integrated solution 6.25 megawatts, and the integrated solution for 3.125 megawatts. And so okay, so I have already come to an end of this presentation. Please feel free to ask if you have any question. Michael, over to you.
Thanks, Habibul. Great presentation. So just I found that one slide very interesting, where you had all these savings about actually about your basically asset or O&M quality control technology. How much is that being used, and how much are customers really interested in that?
Yes, mainly, what can I say? This IV curve scanning and Sineng Energy Cloud been using from 2020 last year, and many clients are very interested in it, because it ultimately save the operation and maintenance cost, and other kinds of any kinds of hassle for due to the operation and maintenance.
Okay. Can you just talk a little bit? You showed basically where you're active. You're producing in China. You're producing in India. So what are your current capacities, and what are your expansion plans these days?
We have two manufacturing bases. One is located in Wuxi, China. Another one in Bengaluru, India. Wuxi manufacturing capacity is 13 gigawatts annually, and Bangalore factory annual manufacturing capacity is 3 gigawatts. But we have a that Bangalore factory will be extended to 10 gigawatts, and same will be done for the Wuxi factory by the Q3 of 2021.
So that means you have in Wuxi then 23 and in Bangalore 13. So in total 36.
Yes. No, in Bangalore it will be 10 gigawatts. In Bangalore it will be 10 gigawatts, and in China it will be 23 gigawatts.
Okay, so okay, understand. So 23.
Yes.
33 almost. Okay, and just a bit about your products. So the new products you will also show at SNEC, will they be available worldwide?
Yes. No, there are some specialist product for Chinese market. I have shown you once. How can you say that high current inverter, that is for the China market, but the same series different model inverter is available for industrial market.
Okay. There's one question here from the audience. So if you look at the different wafer formats, so G12, M10, M6, so which is preferable from your perspective? And of course, that depends on the portfolio and the different products, but maybe you can once again summarize and answer that.
Actually, just now I showed you that for string inverter, all kind of module rating is okay. It is fit for all kinds of short circuit current that goes up to Z12 or M12 wafer size. And as I said, that central inverter, there is no constraint in designing the array because it has high short circuit current. So there is no problem. Whatever the module size you can use, there is no issue with it.
And that's how it should be. If the module guys go fast, that everyone else actually is able to cope with that quickly. So great. Thanks, Habibul, for this wonderful presentation. You're staying with us. If anyone still has questions, please write it in the chat, and Habibul will try to answer them in written form. Let's continue.